Assalamualaikum warahmatullahi ta'ala wabarakatuh. So today, based on assignment 1 and 2, problem reaching a destination, we need to write a program using SWI-Prolog. And I want to explain rules in assignment 1. Rule in AI is provide some description how to solve a problem that can be defined as if-then structure. So here, knowledge base and working memory. So knowledge base contains all the rules, fact, and logic, while working memory contains fact or data about the current situation. So rule number 1, if distance greater than 5, so in working memory, distance is 15, it is greater than 5, then drive. So the action here is drive. So rule number 2, if distance lower than 15, so here distance is 8, it is lower than 15, so distance 8 in working memory, and time lower than 15, so here time 12, so it is lower than 15, then drive. So we go here, the action is drive. So rule number 3, if distance greater than 1, so here distance in working memory is 8, it is greater than 1, the time is greater or equal by 15, so time here is 15 in working memory, then the action is walk. Rule number 4, if drive, okay, it means drive and location city center. So here in working memory, location city center, we go here, then the action is take a taxi. So we go action take a taxi. Next is rule number 5, if drive in working memory, it means drive and location is nothing, location here, then drive your car. So the action here is drive. Rule number 6, if walk, okay, it means walk and the weather is bad here, weather is bad, then take an umbrella and walk. So the action is take an umbrella and walk. Last is rule number 7, if walk, so it means walk and the weather is good, so the weather is good, then the action is walk. So that's all from me today. Thank you.
Hi, Assalamualaikum. My name is AMIRA and I will present regarding components of expert system. For the knowledge base contains essential information about the problem domain and often represent as facts and rules. This knowledge base basically stores domain and with the specific information. For the inference engine, mechanism to derive new knowledge from the knowledge base and the information provided by the user and often based on the use of rules. Basically, it derive new knowledge using rules. User interface, interaction with end user, and development and maintenance of the knowledge base, which means facilitate user interaction and knowledge-based maintenance. Knowledge-based, the problem of reaching a destination. This is the visual representation of the knowledge base within the expert system. Based on rules, we will follow the rule 1 to rule 7, and the facts inside the knowledge base will be drive, walk, take a taxi, drive your car, take an umbrella, and walk. Working memory. This is the visual of the working memory. Meaning that knowledge base and working memory interact with the inference engine. Inside the working memory, also known as the working storage, is distance, time, location, weather, action. This is all the key elements. For the inference engine, initialize, start the non-fact information like distance, time, location, and weather. Apply the rules. Look at each rule from 1 to 7, one by one. Each rule has condition and an action. Match fact to condition. If match the condition of rule, then perform the action specified by the rule. Add new information after performing an action. Add any information in the list of facts. This could be a new action like drive or walk. And then repeat again the rules. Keep checking the rules, and then stop when done. The user interface, enabling user interaction and information display. This one, the UI will be explained by my ID group members, and that's all from me. Thank you.
Hi and Assalamualaikum. My name is ANNESSA ZHAFIRAH and I'm about to explain on the forward chaining expert systems, where I will guide you through how this technique works using a simple transportation decision making example. Basically, forward chaining is a data-driven reasoning method which it will start with a known facts such as a distance, time, location, and weather if I based on the rules that have been given, and then it applies rules to deduce the new information. Keeps firing, matching rules step by step until it reaches the final decision or our main goals. First, is the knowledge base used by our expert system. There are 7 production rules in total. Rules 1 until 3, it determines the means of a transportation, whether to drive or walk, based on a distance and time. For the next rules 4 until 7, it determines the final action, like taking a taxi, walking, or driving your own car, based on the means or other conditions like location and weather. Let's look into the scenario 1, where the system needs to make a decision based on the following facts. So I put an example. For distance is 2 kilometers, time is 10 minutes, the location is in the city center, and the weather is bad. With those facts, the forward chaining process will begin. So rule 2 applies for the first because the distance is more than 1 and the time is less than 5 minutes. We infer that it means it should drive. Now that we know that the means is drive, we check the locations. Since we are in the city center, this is where the rule 4 applies. So we conclude that action, we should take a taxi. So this is the table, shows the step-by-step of the interaction of the reasoning. In interaction 0, our working memory includes distance, time, location, and the weather. Rules 2 and 3 are matched. Rule 2 is fired first. In interaction 1, with means equals to drive, rule 4 matches and is fired, giving us our final decision, it should take a taxi. The system then halts because there are no more applicable rules that can be applied or fired. To conclude our forward chaining for our expert system, forward chaining is basically an effective method for reasoning in expert systems. It takes known facts and applies rules in a logical sequence to arrive at a conclusion. In our scenario, the system correctly determines that the best action is to take a taxi.
Okay, thanks to Lisa for the various explanation. Okay, I will start with prologue. So firstly, I will start with prologue editor for create the program. Okay, so I will create first rule. Is drive distance. Declare as D. D refer to first rule. D must less than 5. So I will continue second rule. So I will continue to rule number 7. Action. Take an umbrella. And walk. Means drive. This walks. So after continue the rule, we continue to iterative input system. So start right, the distance. LSD. After finish, we create the program. So we'll save the file first. All file and okay. So after create the SWI-Prolog, we will try from SWI-Prolog application and we'll start with browser and we'll choose all file and table expert. Okay, let's try. If I start, so the system asks about the distance, so I will create distance and enter time is 25 minutes. I will set city center and location is good, weather is good. So recommendation means the sport drive. Recommendation, drive your car. Okay, this is the testing by SWI-Prolog and look good. So that's all for our explanation, our presentation. Thank you to Prof. Azlan for watching this presentation, and thank you for all my group. That's all of us. Thank you.